Good evening, everyone. It's Ian Lowry's again here from North Essex Astronomical Society. We're going to do a bit more live astronomy tonight. We've been blessed with two nearly clear nights in a row. Hopefully this evening we'll be able to take a look at a few of the objects that we didn't manage to see last night because cloud was getting in the way. Had a few technical gremlins with the equipment today, but hopefully we sorted those out. But fingers crossed we won't have any more of those issues. However, obviously things can always go wrong in tomorrow's world fashion, so let's just keep our fingers crossed. So we're going to start off with an interesting object that many of you will know about in the constellation of Orion the Hunter. Now Orion is pretty easy to find in the sky at the moment. It's high in the southwest, so again, as we did last night, if we go outside and we look where the sun set in the west, you should actually just be able to see fairly high up still Venus. It's the really bright star looking object. It's actually our one of our nearest neighbour planets, a bit smaller than the Earth, but usually the third brightest object in the sky. You should see that high in the west. That is really obvious. It's the brightest thing up there. If we turn around and face south, so we get Venus sort of not quite on our right hand side, but if we turn around and face south, you may be able to see due south another really bright star, which is Sirius. Now this is the brightest actual star in the night sky, and just above and to the right of that we will see Orion the Hunter. Now Orion is pretty easy to spot. What you need to look out for first is Orion's belt. So this is his belt here. It's a line of three really bright stars, quite close together, and then you will actually see that you've got his feet and his shoulders and his head above and below. So if you look down here, you'll see Rigel to the bottom. That's really quite bright, and you also see Betelgeuse, which is a red supergiant star. It's approaching the end of its life now. People have been getting quite excited about that recently because it goes through periodic dimming periods, as all red giants do. It changes brightness, and that's largely because it actually changes size quite dramatically because it's getting to the end of its life. It goes through quite big flare-ups where it gets a lot more energy inside and expands, and actually gets dimmer because it's expanded. And then it cools down and shrinks and gets a bit brighter again. It's also throwing out lots and lots of dust clouds around it as it gets to the end of its life, which also make it dim. But unusually, Betelgeuse has been really dim, dimmest it's been for many years. Normally, Betelgeuse is quite red and Rigel's quite blue, but they're about the same brightness. But over the past few months, Betelgeuse has been quite obviously much dimmer. Still very interesting star. Now it could blow up at any point, and by that I mean it could blow up tonight or it could blow up in a million years time, but at some point in that period of time it's going to blow up into a supernova, and that will actually then become an incredibly bright star for a couple of weeks. It'll be so bright that you'd actually be able to see it in the daytime sky quite easily, and it will probably be as bright as the full moon at night at least. So keep an eye on that. It could happen. It might be in a very long time in the future, but it is imminent in astronomical terms. So the object we're going to have a look at is something that's at the other end of its life. So Betelgeuse is very close to the end of its life. We're actually going to look at the Orion Nebula, or M42, the Orion Nebula. So if we look at the three stars of Orion's belt, we go down a bit, you'll see another three fainter stars pointing downwards, and this is Orion's sword. And even on a night like this, you should be able to see, provided you're out of light polluted areas, you should actually be able to see three stars, one above the other. And if you look at the middle star, it's a bit fuzzy and blurry looking, and that's because it's got the Orion Nebula in it. Now if we switch over to our live view, I've been taking some images of the Orion Nebula tonight already just to get us going, and what we see here is a huge cloud again. As we looked at some of the nebulas last night, this is a huge cloud of gas, mainly hydrogen gas, and also a lot of dust. And right in the middle here, there are some brand new stars. There are four really bright stars really close together called the Trapezium, and they're brand new stars that have formed in probably the last few years. So I think that they probably formed about 300,000 years ago or so. So they're not very old in any kind of galactic terms. Maybe if we zoom in a little bit, if we can get a bit closer and change the brightness a bit here, you might be able to see. So you can see the Orion Nebula stretches out quite a long way. If we reduce the brightness of everything a bit, you'll see in the middle here. I'll zoom in some more. In this area here, it's quite bright, so it's quite hard to see. This is where the four stars, the trapezium, are formed from this cloud of gas and dust, and they are so bright and so hot that are actually making this whole cloud of gas glow. So what you really need to imagine here is it looks sort of flat. Obviously, because we're seeing it, from a very long way away. But if you kind of imagine, it's more like a bowl. If you imagine a sort of goldfish bowl type shape, and we're actually looking at bowl here, and in the centerpiece here, this is where the stars are, and this is the whole outside piece. And what they're actually doing is they're giving off lots of ultraviolet radiation, the stuff that gives you suntans and gives you sunburn. And that's actually heating up all of this gas, and it's making it expand. It's blowing a big bubble in the center of this huge cloud of gas, like a bowl, and all that gas is getting blown away. And so no new stars will form in this area once this process is finished. But in the meantime, it makes all of the gas glow, and you can see sort of down here, you can actually see some dust lanes as well. So there's a lot of dust in these nebulas as well as gas, and that's what the planets and other rocky bodies and solar systems form from. So the gas mainly goes into forming the gas giant planets and the stars themselves, although there's a lot of dust inside them as well because it's all mixed up together, and then we get rocky planets forming from these clouds of dust. So we're seeing it in black and white as ever with this camera. It's a bit more sensitive to see things in the night sky. But here is an image that I took of the Orion Nebula a couple of years ago, I think now. I mean, again, took this from my garden using a similar telescope to the one we're using tonight, but a different camera, a standard DSLR camera. And you can see the coloration is quite red. There's also some greeny glowing stuff, which is, again, is kind of the gas glowing. This fooled scientists for many, many years because they couldn't figure out where this green glow came from. In the early days, they were trying to work out. They understood why hydrogen glows red. It's because the electrons are getting excited in hydrogen atoms, and as they jump up and down energy levels, they give off this red light. But there's actually also green component of light they give off, but you can't actually recreate it in a laboratory on the Earth. Generally speaking, the conditions aren't right. You need things to be really cold and all of the gas to be quite spread out and not interacting for this glow to appear. So for many years in the early years of working out what this stuff was made of, they couldn't really figure out where the greenish kind of glow came from. We understand it now. It's just because it can only really happen in the conditions you find out in deep space. And again, you can see quite clearly here, this dark stuff, these are the dust clouds. Now off up to the right, up to the left, sorry, you can see another nebula. This is part of the Orion Nebula, and this one's actually called the Running Man Nebula. You may just be able to make out a little shape of a little man in this bit of the nebula. It's all related. Again, if we go back to the picture that I took previously, you will be able to see again the colours. You can see here that again that this is quite green and glowing. You can see much more clearly the little running man. They get this to come out in different colours depending how you process it. It's come out a sort of pinky, greeny, reddy colour in this image. Depending on what your preferences are, you can make it come out looking slightly different. So that's the Orion Nebula. As I say, really, really easy to find in the sky. Again, if we just go back to the planetarium here, again, all we need to do is look this time of year to the south. It'll always be in the south part of the sky, either rising over in the southeast. high up in the south or setting in the southwest during the winter and winter months. So kind of quite late on in the winter, it starts coming up early enough to see it. Then through the sort of first part of the year, it's really visible. Look due south, you should see Sirius, really bright star, and off to the west you should see Venus, and between the two we see Orion's belt. If we look below Orion's belt, we see the Sword, and in the Sword we've got the Orion Nebula. This is this piece here. So to give you an idea of the scale, we looked at the live view. You can see this is where the Running Man Nebula is. This is one of the stars in the Sword. Then the Orion Nebula is around the other star, and then the third star is down a little bit further here. Now, to give you a bit of an idea of the scale of this, actually the whole of the Orion Nebula has got a huge, massive cloud of hydrogen gas and dust. If you take a really long exposure image with a wide angle, you'll see there's huge loops of gas all the way around here, this whole area, and this is one of the big star forming regions that's near to us. Very, very easy to see. Some parts of it, other parts of it are quite faint and need photographing, but you can maybe not just to make out here this pink piece. This is called Barnard's Loop. This is part of the nebula, not something really possible to see by the naked eye, but certainly in long exposure photographs it's really very bright. So that's the Orion Nebula. Now we're going to see if the technology is going to cooperate with us. So we'll just take one last look at the live view. I've been collecting data for quite a while, so we've actually got about 20 minutes worth of exposures on this image. And you can see if I change the brightness and contrast, you can see different features in the middle. You can see actually if we really push it up, you can see that this extends out quite a long way, and actually there's even more stuff out there if you put a really long exposure in. What we will do now is we will disconnect the camera from here. We will go back to our other piece of software and connect the camera in here. And fingers crossed, what we will now do is we'll try and go to another nearby object. So we will move to that object, which is the Horsehead and Flame Nebulas. We'll have a look at those in a minute. So we'll wait for the telescope to stop moving. Just bear with me, we've got lots of different bits of software going on here as ever. It takes quite a while to figure it all out, and sometimes it all goes horribly wrong because it's quite complicated, but never mind. Sometimes it works quite well as well. So now we are going to try and center on this. Again, we will take a couple of images and see what happens. So we basically take a picture, we wait a few seconds to see where we are in the sky, and the software will work out, has a big database of all of the star positions. It can work out exactly where the telescope is pointing, and it can figure out if we're close enough to where we want to be. You can see we've got there first time lucky because we haven't moved very far in Orion. And now we can disconnect the camera from this bit of software, go back into our other bit of software and reconnect the camera. We will up the exposure time to 30 seconds. We'll start picture. So we just wait a minute or two. We'll start getting some stuff. So while we're waiting for that to happen, we will go back and have a look at where we've gone in the sky. So we haven't moved very far. So we started off here, roughly is where the Orion Nebula is, and we've actually just gone up to Orion's belt here. So rather than being down where the Sword is, we've just gone up to the left-hand star in the belt. It's quite a bright star called Alnitak. Now, what we're going to be looking at is a nebula that many people have seen, quite famous. It's called the Horsehead Nebula. I'll hopefully get some images of that in a minute. So we just bear with us a second. We've got here. A lot has to be said. Just bear with me a second. Sorry. Should get some if we're in the right bit of the. Who knows? Sometimes you get lucky, sometimes you don't. And we are. So at the moment, we don't seem to be getting much in the way of exposures. We'll try again and see whether we get anything. So just bear with me a minute. Right, okay, much better. Okay, right, we've got something coming through now. So I will switch to the live view. So when we talked about Alnitak, this is this bright star here. This is the left-hand star in Orion's belt. So if you look at the little planetarium view just down here, you can see it's the left-hand star in Orion's belt. That's the one we're looking at. We're starting to see some of the nebula appear now. We push the brightness up a bit. So it'll probably take a couple of minutes to give us what we need, but we'll really ramp the brightness up as much as we can. A little bit more. You can start to see something's coming out now. Bright. Here we go. Much better. Okay, so we now push that up a bit. So I'm going to zoom in a bit, so you'll then be able to see what we're looking at. Okay, so this is the Flame Nebula. So this piece here is the Flame Nebula, and this is the famous Horsehead Nebula here. What you may be able to see is they're basically the same stuff. Again, it's hydrogen gas that's being illuminated by a bright star, nearby bright star, and there are lanes of dust. And in the case of the Flame Nebula, all this dark stuff is actually in front of the hydrogen gas, which is behind and glowing. That's all this dust blocks out parts, so it makes it look like a sort of flaming fire. Over here we have the Horsehead Nebula, and again we've got a load of hydrogen gas glowing here, just about to see it in the background. And then below it, actually, we've got a really big dust cloud, and a bit of it is poking up, and it makes a shape like a horse's head here. Now you can tell there's a big dust cloud here. If you actually look just above, you can see there are lots and lots and lots of little stars in the background here. If you look below, you can only see very few stars, which are actually in front of the dust cloud. And they're actually obscuring all of these other background stars, which you can see at the back here. So again, perhaps we'll zoom in a little bit further. Just center that in the middle of the screen. You can see it's starting to come out now. Again, maybe we push the brightness up a little bit more, and we background down a bit. That's great. Now you can really see what we're talking about. So again, we've got the Flame Nebula here. We've got the Horsehead Nebula here. We've actually got a little dusty nebula as well around this star. Now all of this is being illuminated by one of our members, Simon's favourite object, which is a star called Sigma Orionis, which is this star down here. So it's not Alnitak, although Alnitak's really bright. It's actually not that close to these nebulas, whereas Sigma Orionis is, and again it's doing the same thing. It's giving off loads of ultraviolet radiation. It's actually heating up the gas and making it glow. Now the interesting thing about Sigma Orionis is actually it's a multiple star system, and if you put a powerful telescope on it and you look at it, you'll see there are lots of stars. There are actually 6 stars. They are gravitationally bound, so they're all orbiting around each other. So it's a bit like, if you remember Planet in Star Wars, when Luke Skywalker's in the desert and you see 2 stars in the sky. That's not quite as unusual a scene as you might imagine. You actually do get lots of double and multiple star systems. They're very, very common in the universe, probably more common than single stars on their own, actually. In this case, we've got 6 stars. and it is entirely possible, and we've found planets in these systems, although we originally thought it might be quite chaotic and difficult for planets to get into orbits around these stars because there's so much gravitational interaction going on between the different stars. Actually, you can get planets in these multiple star systems. So if you're in this star system, you probably would see several suns in the sky. Now, if I recall rightly, each of the sort of components is a double star in its own right. So there are two stars quite close together, so you might very well get that kind of double sunset effect on one of the planets going round the double stars, and then the other two pairs are quite a bit further away from each other. So you probably wouldn't have sort of 4 or 5 or 6 suns in the sky. What you probably would have is 2 suns and some really bright, stars. Again, you're probably much brighter than something like Venus because they're quite nearby, but they'd be far enough away that they will probably look like stars rather than actual suns. So that's Sigma Orionis, and that's actually what's illuminating the Horsehead and the Flame Nebula. So if we go back to the live view, again, what we can see is, sorry, just back that back up. We can see that we are now starting to get, yes, a very nice view building up. Again, sorry, just pull that back a bit there. And we don't want the background to be completely black. The sky is actually glowing quite well. So what you can see, as I say now, you can really see the structure starting to come out. So what you've got here is you've got this really dark dust cloud at the bottom here, and behind it you've got a glowing sheet of red hydrogen gas, and a bit of the dust cloud is looping up, making a shape like a horse head. You can see you might be able to see there's a streak here. This is probably a satellite that's zipped through field of view. It makes streaks because we're continually exposing. You can see that Alnitak is quite bright, and then Sigma Orionis is somewhere off to the side of this view. So we bring the whole thing out again. You can get a bit of an idea. There you go. So there's Sigma Orionis up here, and this is the one that's illuminating all of this stuff. So if we have a couple of facts about that, the Horsehead Nebula is about 13 to 1400 light years away, and the Flame Nebula is about 1500 light years away. And there are stars actively forming in both of these areas, as well as the young stars that have already formed. Now we can have a look at a photograph that we've got of this. One of these images here was taken by Martin Bracken, who's one of our members. He only really started astrophotography quite recently, but he's very keen, and he's already starting to get some great results. So it is challenging, but it is not as difficult as you think to get started. You can see with several hours of exposures that you really start to get the whole idea of how this looks like a horse's head. And again, in the background, you've got all of this glowing hydrogen gas. At the bottom, you've got all of this dust that's actually blocking out the glowing gas behind it and the stars behind it. We've got another image of the whole area. This one was taken by Alec Alden, who's again is one of our members, and he is a very keen astrophotographer as well. He's been at it a while now. He's getting some really good results. And if you take a colour photograph, you can definitely see what's going on much more easily here. So again, you've got this lovely red colour. This is the hydrogen gas that's glowing from the energy of Sigma Orionis that's heating it up. Below, you've got the black dust. And over to the right here, we've got the flame, again, which is hydrogen gas. You've got all these dust lanes in front of it. You've got Alnitak here. It's quite challenging. It might look a bit funny in this picture. One of the problems of taking long exposure pictures of this area is that this star is so bright that it just tends to wipe everything out. Really hard to get it right. And as I say, you can see in front of this star here, and indeed this star here, there's some blue stuff, and this is actually a reflection nebula. So we've got a lot of dust around this star and a lot of dust around this star. You can kind of start to pick some of it out in these areas as well. And the blue light from these stars is actually just reflecting off the dust, which is why we can see it. Again, if we go back to our live view, you can definitely see now that the whole thing's built up quite nicely. Really has got some detail coming out. A bit more, see if we can get a bit more out of it. See these strings of hydrogen gas here, black dust, and the Flame Nebula. So that's That's the Flame Nebula and Alnitak. So again, just reminding ourselves of where that is. We go back to the planetarium. We're just on the left-hand star of Orion's belt. Flame Nebula, if you're looking at them to be standing upright, is up just up and to the left, and the Horsehead Nebula is just below. So pretty easy to find, as I say, but not very easy to see through a telescope, unlike the Orion Nebula, which you can see with the naked eye or very easily with a small pair of binoculars. But as I say, that this whole area, you know, that there's tons of this stuff around this whole area in the Orion molecular cloud. So that is the Horsehead Nebula and the Flame Nebula. So what we will do now is we will try and find our third object for the night. We just dip over here, reconnect the camera. We are going to just not going to go too far away. We are going to move with. Oh, right. Let's go here. So first of all, we will move to the target, and again, we need to wait for this to stop moving. So switch over and just see what's going on behind the scenes again. You can see the numbers up here that show you that the telescope is moving. Once the numbers stop changing rapidly, it means the telescope has got to where it needs to go. I suspect that it will take a little while because, again, as we said, with the type of mount that we're using, the equatorial mount, sometimes it's got to go on quite a long journey just to move a short distance. It's got to flip itself around and point from the opposite direction. So we might have been pointing at the Orion Nebula this way, and we actually need to flip the telescope way around so it's pointing the other way, even though it's just slightly across in the sky. It's just the nature of how these mounts work. So it takes a minute or two to get to where it needs to get to. So hopefully we'll get there in a minute. Right, so I think we're there. We'll start this thing going again. This piece of software here just helps us to keep on target. It uses a separate telescope, separate camera, just to take images of the night sky every 3 seconds or so. And then when I tell it to, it'll actually just track the position of whichever star we've picked. And if it sees the star moving, it will tell the telescope mount to move the opposite way just to keep everything in the same place. So we've actually got 2 telescopes working tonight to do this job. What we'll next do is we'll try and center this object to make sure that we are in the right place. I suspect this will take a little bit longer because we have flipped quite a long way around the sky. So we might be off by a little bit of a distance here. Again, as I say, this software's got a big database of all the stars in the sky. It knows where they all are, all the bright ones. And what it will do is it'll take an image and it will actually find all of the stars, and it will then do a bit of a sort of jigsaw puzzle type pattern matching process where it matches up stars in the image with its database, and once it's done that, it knows where it is. So we'll just stop that if it's moved. Sometimes it just goes a bit too quickly. Try again. For some reason, sometimes it tries to take the second centering image while it's still moving the telescope. It's a little bit annoying. You can see that the stars are a bit streaked here, and that's because it's taking an image while the telescope is still moving. It's happy now it's in the right spot. So what we will do is we will then again disconnect our camera here, go back to our other bit of software. The reason we're using 2 different bits of software simply because this software will actually, the software that we're using here will actually stack. It will combine the images to average them all together, and that gives us a much clearer view. So again, we will wait for that to work for a little bit, and while we're doing that, we will take a look at where we are in the sky again using the planetarium. So we've been over here, we've been looking at the Orion Nebula and the Flame and Horsehead Nebulas in Orion. Quite an easy constellation to find. The next object we're interested in is in a constellation that's very hard to find. It's Cancer the Crab. So it's one of the sort of constellations in horoscopes. We don't believe in that kind of stuff, but the ancients did. you can't really see much of it. It's just a bunch of dim stars in a bit of a sort of X shape. Really hard to pick out even in a dark sky. But the easy way to find it is to find Orion, and if you go up to the right, you'll find two bright stars here called Castor and Pollux, which are the heads of the twins in Gemini, and they're really obviously about the same brightness and quite close together. Then further over again, you've got Leo the lion, so you can see the lion's head here, and he's sort of sitting down a bit sphinx-like. And yeah, so Orion, Gemini, Leo, and between the two we've got Cancer. Hard to find, but the object that is in it is very easy to find. I actually search for it so we get exactly in the right place. What we're looking at, Beehive cluster. Not you, definitely not the right one. Oh, I went there. Not what we're looking at. Wrong button. It's down there. It isn't. I can assure you. It's this bunch of stuff here. So this is what we call the Beehive cluster. This is in Cancer, the crab. Now, as I said, finding Cancer itself is quite hard. It's quite a dim constellation. Yeah, I think we're struggling a bit here. Our images to work. We will try again. 30 seconds sometimes. Use. So definitely haven't got cloud problem. Because we're not guiding, maybe better. Right now, good. Okay, so we are looking at the Beehive. So let's just go back to what we were doing. Sorry about that, people. So the Beehive cluster is right in the middle of Cancer. It's quite hard to see the constellation, but it's very easy to see the Beehive cluster. It looks like quite a nice fuzzy patch of stars in the sky. It's a bit hard to figure out. It's a cluster of stars without a telescope, but even in a small pair of binoculars, you'll start to see it's a cluster of stars. It looks like a little fuzzy patch halfway between Leo and Gemini, so Castor and Pollux and Leo. Once you find it, it is quite pretty, particularly through a telescope. So if you go to the live view now, you can see we've got lots and lots and lots of stars in here. It's quite a beautiful sight. Now, this is what we call an open cluster, so it's a bunch of stars that are quite a fair bit across, but the whole cluster itself is about 23 light years across. So give you an idea, the nearest star to the Earth is Proxima Centauri, which is a red dwarf star that we can't see from the UK, but we certainly can see it from the southern hemisphere with a telescope. That's only 4 light years away, so that's the nearest star to the Earth, and even that's a really long distance. But this whole cluster is about say 23 light years across. The stars themselves are about 600 million years old, and coincidentally, they're about 600 light years away. All in all, in this cluster, we think there are about 1,000 stars. There's a smaller number of bright ones and quite a few dimmer ones, as you would normally get. So this is the Beehive cluster, again in Cancer. Now again, I have got a view here of it. So just bear with me a second, I will bring it up for you. This is a nice one that I took. So this is back in January 2019. I was up at 4 in the morning to see this. And what you can see is up here is where the Beehive cluster is. We actually had a total lunar eclipse at the same time. So this is actually the moon pretty close to the total eclipse. So you can see that what's happened is the moon has gone into the Earth's shadow, and it turns this lovely copper gold, sort of copper brown red colour, depending on what's going on in the Earth's atmosphere. Because even though the Earth is completely obscuring the sun from the moon's point of view, so it's dark, you can't see the sun. The actual Earth's atmosphere, light bends through it, and actually what you would see if you were on the surface of the moon looking back at the Earth is you would see a big black hole in space where the Earth is, and then you would see a ring of red fire, like a sort of circular sunset, where the sun's rays are all bending around through the Earth's atmosphere and still illuminating the moon. And just like the sunset, when we see it ourselves normally, the red light predominates because the bluer light is scattered by the atmosphere, so you end up with this lovely deep red colour. So that's the lunar eclipse, and up here we have Beehive cluster itself. So again, if we go back to our live view, you can see that this is building up now. We've got all of these lovely stars. It's a really nice sight. It's very easy to see, very nice in a small pair of binoculars or a small telescope. Well worth a look, but a little bit tricky, as I said, to find in the night sky. So again, you know, just to remind you, what you need to do is find Orion, which you should be pretty familiar with now. Go up a bit and to the left, you'll see Castor and Pollux, two bright stars quite close together in Gemini. And then you will then see Leo further around to the east. It's line shape's a little bit harder to make out, but Regulus is quite a bright star. Then you will see this sort of backwards question mark shape, and then the rest of the lion's body here. About halfway between the two is where the Beehive cluster is. So that's the Beehive cluster. So we've done that one. So we will now move on to our last object for the night. This is one we've seen before, but it is a nice one. So I'm going to make no apologies for revisiting it. It's one we did try and have a quick look at last night, but didn't have much success. So again, just bear with me a second whilst I do a bit of messing around in the background here. Reconnect my camera. I'm going to go to target over here. Again, we can bring up and show you what's going on in our software. So the telescope is now moving around. So now we're going to move all the way around the sky to be pointing towards the northern part of the sky. So far we've been looking mainly south and southwest. We're now going to be looking up into the north and northeast part of the sky. Somebody's asked what mount we're using. I'm using an NEQ6 mount. It's a bit big actually. I'm using a William Optics GT81, which is an 81mm telescope. The imaging, the actual mount itself is an NEQ6, which is something that can carry a much bigger telescope. The beauty of it is it's really strong and stable, even with a small telescope, even in windy conditions. So it makes imaging quite a bit easier. So hopefully we're now in the right bit of the sky. And again, we're going to play this game of trying to see if we can do a bit of what we'll do is we'll try and center on the objects we're interested in now. So what we'll do is center on target. Again, you know how this goes, guys. Seen this happen before. What we're going to do is we're going to take one photograph of the sky. The software is going to compare the database of stars that it's got with the stars that it finds in the image that we've just taken. And it will work out how far out we are from where we need to be. Hopefully that's all still going well. So yes, another capture success. We're in the right bit of the sky, so now we can disconnect from here. We will connect up here. Connect. Chat here. With tracking. Right, wait a second for our 30 second exposures to complete, and we will, whilst we're doing that, what we will do as we've done before is we will go back and have a look at where we are in the sky. So and we've talked about some of the objects in the southern sky. So remember, we've been over here in the southeast, southwest, sorry, looking at Orion. Then moved across to Cancer, which is pretty much southeast, just at the moment, and now we've whizzed all the way around to the north of the sky. So again, remember we talked about this last night. Finding north is pretty easy. Just get the sunset on your west on your left hand side, and straight in front of you will be north. And if you look at this time of year up a bit to your right, you'll see the plough, which is this shape here. We've got the handle and we've got the square on its side. Looks like a saucepan on its side. Follow the two stars across and you've got the North Star. And the bit that we're interested in is actually just close to the plough. So again, I'm going to find it. It's easier than searching around randomly for about 5 minutes. There we go. So what we're looking at is M81 and M82, which are two galaxies that are quite close together. So again, we found the plough, and just off a bit to the left of the plough at this time of the year, we've got M81 and M82. These are the two galaxies that we are interested in. So if we go back and just check where we're going with our live view. Yeah, okay, so we'll switch to live view. And we need to just adjust the brightness of this. So what you can see here is we've actually got two galaxies for the price of one. We've actually got more than two galaxies for the price of one. We'll talk about these two first. So M81 is this galaxy here. This is a large spiral galaxy. It's about 90,000 light years across, and it's about half the size of the Milky Way, but it is very pretty. You can see very easily. Zoom in a bit, even a bit more. Let's go a bit more. Let's go crazy here. Great. You guys can see. Just we go. Right. Very nice. So what we've actually got is this big set of spiral arms here. So this is the center of M81. This is the core, and you've got the big spiral arms, two main spiral arms going around. Basically what this is all these stars are orbiting around the galaxy, and they sort of build up in waves. So these spiral arms aren't sort of solid things. They don't spin like a spinning top. The stars are actually moving in and out of the spiral arms. So they go around the galaxy, but where there is more density, the stars speed up and zip into the spiral arm. They slow down a bit, and then when they start coming out the other side as they're going around the galaxy, they move away from this dense bunch of stars and gas. They'll speed up again. So what is like a sort of a pressure wave of stars building up. So these spiral arms tend to stay where they are. If they were actually solid objects, they wouldn't persist. They would actually just pull themselves apart because the galaxy's spinning so fast that actually just where the stars are slowing down and then speeding up again on their journey around M81. Now, M81 is the interesting one. So you may have remember last year there was that fantastic picture, the first ever picture of a black hole, that big orange ring that they took with the sort of the black hole in the middle, and that is actually where this is, right in the middle of this galaxy here. This is one of the nearest big supermassive black holes, which is why they took an image of it. Much easier to take a picture of than some of the other ones that are further away. Fantastic technical feat, but again proves that these things exist. Now, just over to the side here, we've got another galaxy. Now, this is M82. Now, this is it's about 5 times brighter than our own galaxy. It's not as big, but it is much brighter than our own galaxy. And the center of the galaxy in the middle here is probably about 100 times brighter than our own galaxy center. Now you may be able to just start to see here again. Perhaps if we zoom in even more on this one, dip it into the middle for you. I'll maybe try just Yeah, well, if I dim it, but yeah, if I dim it a bit, you can see all of these lines here. There's actually some really bright, high. Again, remember that red stuff that we saw in the nebulas? There's actually great big streaks of it coming out of the top and bottom. This is called the Cigar Galaxy. And what's actually happened is this galaxy is in close proximity to, so M82 is in close proximity to M81. And we believe at some point in the past it's had an encounter with it, it's passed very close to it, it's been very much disrupted, all of the material's been stirred up, it's going through an intense process of star forming at the moment. It's called a starburst galaxy. All of the gas that's kind of in there has all been mixed up, and it's all collapsing to form loads and loads of brand new stars that are really, really bright and hot, and there's loads of glowing tendrils of gas coming out all over the place. That's M81 and M82. Now, if we zoom all the way out, the interesting thing is actually in this part of the sky, you may be able to see up here, we've got other galaxies. Again, I'll maybe adjust the brightness, make it a bit obvious. This here is another galaxy. This is a galaxy probably a bit further away. Down here is another spiral galaxy, a bit harder to see. Perhaps again, if we zoom in a long way in and get down there, we might not see it. But look, interesting. This here, this is another galaxy. This is probably another spiral galaxy that we're seeing edge on, very long way away. Here you can just about see. Sorry, hang on. So on the edge here, this is another spiral galaxy here. So you know, there are galaxies everywhere we look in the universe. Any direction you look, even in empty patches of space, there are galaxies. This little blob down here is another galaxy that's a really long way away, and if we went through we could pick out loads of them. There's another one there. These two are much brighter because they're a lot nearer to us. So that's where we are. So again, let's just remind ourselves of where we are. I don't think I've got a picture of this one. I haven't, sorry. We threw that one at the last minute last night, so we were unable to get a picture of it. But again, if we go back and have a quick look at the planetarium, just to remind ourselves of where we are in the sky on this last object that we're looking at, very close to the plough. We find the plough, find the two stars at the end of the sort of the square of the plough, and then actually if you go through the middle of the square, a diagonal line, and then carry on the same distance again, that's approximately where these two galaxies are. Probably a bit hard to find in a pair of binoculars, but certainly again in a small telescope, medium-sized telescope, you would definitely be able to see these when we do our stargazing events, which hopefully we'll be able to do at some point later this year again. We often show people these two galaxies. They're very pretty and very nice to look at. So I'll go back to the live view just to see where we're at. Also adjust again. So again, you can see galaxies everywhere here. Let's see if anybody's thrown any questions in there for me. Answered about the mount. About it. Okay, so those are our stars for and objects for tonight. I'll think I've pushed my luck with my equipment, so hopefully we'll be able to get it all sorted out and not have any further problems and try again. We'll see what the weather's looking like tomorrow. If the weather's looking good again tomorrow, maybe we'll do another one. If not, we're certainly going to do some talks. So we often do talks at our stargazing events. We've got some interesting talks that we think we could probably do online. We've all got talks about meteorites. We've got talks about detecting meteorites with radars. So some of these don't actually depend on the weather being good. The challenge for us is going to be obviously the end of the month. The clocks go forward, so it's actually going to be getting dark quite a bit later, and obviously the days are getting longer as well. So as we sort of move through April and May, astronomy becomes more challenging. Stay up later and later. Then we're kind of, once we get into sort of June, really we're struggling a bit to do anything other than perhaps those of us who are night owls. So what we'll do is maybe see if we can get at least one more of these events in if the weather cooperates before the end of the month. And if you enjoyed it, please join us again. Don't forget these videos are on our Facebook page. I am hopefully also going to be in a position to put them onto our YouTube channel as well. If you've got any questions, please post them on this video. I'll just go to our Facebook page and ask away. We'll do our best to answer them today or tomorrow. And again, thank you very much for joining. I think we've been quite lucky with the weather tonight, so much better than last night. Again, thanks very much, and hopefully we'll see you again.